All right, folks, let's take a look at solving absolute value equations. The absolute value symbol is the two bars, and you would read this statement up above as the absolute value of x is, in this case, n, which would be some kind of a number. And what it means is it's measuring the distance from 0. So, for example, if I had this is read the absolute value of -3. And what it means is how far is -3 from 0. It's measuring that distance from 0. So because it is measuring a distance, you're just saying how far away it is from 0. It is always positive because it doesn't matter which direction. So for example, with -3, if this is 0, -3 is over here, but in terms of the actual distance, it is 3 units from 0. And so then my absolute value is 3. My answer will always be a positive number because I'm always measuring the distance. So what about this? This is absolute value of 4. It's asking how far is 4 from 0, which is 4 units, obviously. And this one is asking how far is -1 from 0. So that is 1 unit. So I look at the absolute value and whatever's in there becomes positive. So when you say the absolute value of x equals 5, that could have two different values because you're saying what is 5 units away from 0? Well, 1, 2, 3, 4 positive 5 or 1, 2, 3, 4 negative 5. Both of those are 5 units from 0. So my answer could be equal to 5 or -5. I don't really know which. In this next example, the absolute value of what number, that's the x, is 2. Think about the number line. If this is 0 and I'm 2 units away, I could be 2 units to the right at +2 or 2 units to the left at -2. So I have two options, either positive or -2, because if I had done the absolute value of 2, I'd get 2. Absolute value of -2 would still be 2. So the last example like that is saying, hey, what number equals, the absolute value of what number equals -6? Well, x could not equal anything. This one has no answer because it's telling you that the absolute value equals a negative, and that can't happen. You can't have a negative absolute value answer because you're saying it's -6 units, and that is not a way you can measure something. So when we go to actually solving, we have to keep in mind this business right here, that when you have an absolute value equal to a positive number, there's actually two possibilities. So here we have a 2 on the right, just like we did in this example. That means that what's inside here could have a value of either 2, because that would come out as the 2 we're trying to get, or what's inside the bars could be a +2. So when you go to solve this, you have to take both things into account. What I always tell my kids at the high school is 2 bars means 2 answers. So I'm going to split it up and say either the stuff inside the bars has to equal 2, or the stuff inside the bars can equal -2, because it would still come out of the bars as a +2. So I'm going to go ahead and solve both. I add 9 here. One of my possibilities is 2 minus 9, so -7 is one of my possible x values. Here, when I add 9 to both sides, I'm getting that x could equal a +7. Okay, I made a mistake right here because I had a negative written. So what I was writing earlier is correct. Sorry about that. Because this was a -9, I'm going to add 9. So my 2 plus 9 would give me an 11. Now, if you get all confused like I clearly just did, this is solving. So keep in mind that you can always go back and check your answers. So I could try my 11 and say, well, that would be the absolute value of 2, which would indeed come out to be 2. Then I can check my other possibility, 7. 7 minus 9 would be a negative 2, but the absolute value of that would come out to be a 2 as well. So if you made a little mistake like me, you could catch it with checking your answers. All right, so when I take a look at this, I'm thinking up here, whatever's in the bars could be a 7, or it could be a negative 7, and it would still come out to be that positive 7. So when I go to set up my two equations, I'll have that what is inside has to equal 7, or what is inside will have to equal negative 7. I never change anything about what's in here. It stays 2x minus 1. The only thing that changes is my answer goes from 7 or negative 7, because I'm going to ultimately be doing this thing, taking the absolute value of it, so it'll come out to be that positive 7. Here I need to add 1. So your solving skills, the better you are at solving, the easier this part will be. Then I'm going to divide by 2. So 4 is one of my possible outcomes. Here I still add 1, but now I'm going to have 2x equals negative 6. Dividing by 2x equals negative 3. And just because absolute value can't be negative doesn't mean you won't get negative answers, because I can go back and check these and see if I'm using the correct answers. I'm saying that 2 times 4 minus 1 would come out as a 7. Well, 2 times 4 is 8, minus 1 is 7, and the absolute value of 7 is definitely 7. So that checks out. If I wanted to check my other answer, I would have my 2, plug in my negative 3 that I got. This would turn into negative 6 minus 1. So I'd get a negative 7 on the inside of my absolute value bars, which would come out as the 7 I'm trying to get. So both my numbers check out. All right. So before you can separate this out, you need to have just the absolute value bars on that side. So I'm going to start here by taking away 6. So 5x minus 10 equals 5. Now I have just the absolute value bars, and I can take this and it can equal 5, or what's inside the bars can equal negative 5. And again, I'm not changing what's inside the bars ever. I'm only saying that what's in there can either equal a 5 or a negative 5. So I start solving each equation. Add my 10, divide by 5. 3 is one of my possibilities, or go ahead and start over here. You're going to be doing a lot of the same steps. This is going to combine to give me a 5. So dividing by 5 on this part, I get a 1. All right. And if I needed to or wanted to, I can go back and check those answers. In my last one, I have a couple of things. I have to get rid of the 4. I have to get rid of the 6. So the first thing you get rid of is the thing that's added in there. So I'm going to subtract that 6. That'll go away. I'll still have my 4 out in front of the absolute value, and then here I'll have a 24. Since the 4 is multiplied in, I'm going to get it out of there by division. So 2x plus 8 in the absolute value bars will equal 24 divided by 4, which is 6. Now that I have just the absolute value, I'm going to go ahead and split these up. Keeping in mind that I never change what's in the bars, I just let it equal 6, or I take what's in the bars and let it equal negative 6. Because whether I have 6 in here, it'll come out as a 6, or if I get negative 6 inside the bars, it'll still come out as this 6 I'm trying to get. So solving each, I get one possibility is that x could equal negative 1. Over here, I get that x could equal -7. And again, I can go back to my original problem and I can put in those values to check. I'll just show you one. For example, I could put in my -1 into the original problem and see if it actually does equal 30. So inside here, this would turn into -2 plus 8. So then these would turn into a 6. The absolute value of 6 is 6, so these would turn into 24, and that would indeed equal 30. So it checks, and then I could repeat that same process by taking my -7 and putting it in here. So hopefully that'll give you good examples to look at. Couple things that you really want to keep in mind is that a straight up absolute value has to equal a positive. And down here, all the solving steps are the same as we've ever done. You just have to be careful that you split every problem into 2 problems. So 2 bars, 2 problems, 2 solutions. Have a great day, guys.